I-2, so we're still on I-2 graphing functions. And this is module 2, so we're going to do square root functions. So before we start our square root functions, we're going to remind ourselves what is a square root. So remember, square root looks like that kind of division sign, but it has that little tick on the outside. And the point of a square root is we use it to undo repeated multiplication. So to undo repeated multiplication, what we mean by that is if I think of what is the square root of 25, I want to know what times itself is 25. And I could use my calculator for that. Square root of 25 is 5. Because 5 times 5 is 25. Okay. We could do the square root of 14. Now that's going to be a decimal number, and that's okay. Square root of 14, we can estimate is about 3.742. Okay, if I take 3.742 times 3.742, let's see what we get. We get 14.00. It's a little off, but it's pretty close. That's pretty close to 14. Okay, big thing here is remember if I take a square root of like a negative 16. Now we might see that 16 and think it's 4, but remember 4 times 4 is positive 16, and negative 4 times negative 4 is a positive 16. So if we do a square root of a negative, we get that undefined. There's no real solutions. Okay, that's going to be kind of important as we play through what we do today. Okay, we're going to follow really similar steps to yesterday, so let's name our steps. Okay, yesterday when we did absolute value, the first thing we did was we found the vertex each time. We did our vertex, we made our table, we graphed, and then we did our domain and range. Instead of a vertex, this time we're going to have what we call a starting point. So step 1 is going to be to find the starting point. And our starting point this time is when the square root equals 0. Because remember, we can't have a square root that's a negative. So that starting point, because we can't have that negative, is always when it's 0. Okay, step 2 is then to make our table. Step 3 is to make our graph. And then our step 4 is going to be to do our domain and our range. All right, here we go with the first one. So if you don't have a graph already, find a graph. We're going to glue that in. So we have y equals the square root of x. Okay, so first thing we're going to do is find our starting point, which is when does that square root equal 0? So square root equals 0. In the square root we have x, so we just get rid of that square root. We could undo it by doing squared on both sides, but we just get x equals 0. So my starting point is 0. Now this time when we have a starting point, rather than a vertex, vertex is always that middle because it's the minimum or the maximum. Our starting point is where we're going to put at the beginning. So we're going to do 0. We're going to do 1, 2, 3, 4, 5, and 6. We're going to go all the way up to 6 this time. And then we're going to just plug those into our calculator. So in this problem, we're doing square root of x. So my first x is 0. So square root of 0, oops, not O, is 0. And delete the 0, put in a 1. Square root of 1 is 1. Square root of 2 is 1.41. So not quite to 1.5. And it's okay for us to use decimals this time. Square root of 3 is 1.73. Square root of 4 is 2. Square root of 5 is 2.24 about. And the square root of 6 is 2.45. So there's our table. Our next step is to do our graph. So we're going to plot these points. So we have 0, 0, and that's our starting point. So we're not going to go beyond that. Just kind of stays there. Okay, then we have 1, 1. So right 1, up 1. 2, 1.41. So I'm going to go to 2. Now 1.41 tells me to go to 1, and then about not quite halfway. So it's actually going to be in between 1 and 2. So about 1.4. Then I'm going to go to 3, and this time it's 1.73. So I'm going to go to 1, and then this is about, well, it's over halfway. Four is 2. 5 is 2.24, so I'm going to go to 5, and then we're going to go up 1, 2, and then 0.2, so about a quarter of the way. And then 6 is 2.45, so about 2.5, so 6, 2, 1, 2.5. So this one is going to go up, and it only has one arrow. It's going to go in that direction, and the starting point, we have a curve. That's really important that it is curved. We have that arrow going in that direction. Okay, so let's do our domain and our range. So for our domain, we're going to think left and right. So from my starting point, am I going to go left anymore? Nope. Am I going to go right? Yep, it keeps going right and right, right. So what's the farthest left? Where does it stop? Well, it stops at that 0. So I want x and 0. And I'm going to think on my x-axis, am I doing numbers bigger than 0 or less than 0? If I'm not sure, I can look back at my table. Are my x's bigger than 0 or less than 0? And they're bigger than 0. So we're going to do x is greater than or equal to 0. And for our range, we're thinking our y's, so we're thinking up and down. And we see that this graph is going to keep going up, 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 up. It's kind of slowly going up, but it doesn't keep going down. It has that stopping point here. And on our y-axis, that stopping point is 0. And again, that graph is going above 0. These numbers go above 0, so it's greater than 0. But it could also equal 0 because we have that 0 there. So there's our first equation, our first graph. We're going to do 2 more. All right, next up we have our f of x equals 3 square root of x plus 5. So if you need to write that down, take a jot there. Okay, before we make our table, the first thing we're going to do is find our starting point. And our starting point is where the square root equals 0. So I'm going to think what's in the what's in the square root? And in the square root we have x plus 5. That plus 5 is in the square root. So some of you might be able to do this in your head. Some of you might need to write it out, and that's okay. So we're going to have x plus 5 equals 0. And we're going to solve that equation. So to undo an adding 5, we're going to subtract 5. And if we do that on one side, we're going to do it on the other. And 0 minus 5 is going to be negative 5. So now when I go to my table, I'm going to have my x, and then instead of y, I'm going to use that f of x. That tells me that what do I get when I put that into the function f, and my x is going to start at negative 5. And then I'm going to count up, so I want to make sure I'm counting towards the positives. So negative 5, negative 4, negative 3, negative 2, negative 1, I'll just go up to 0. We could keep going on and on past that, but we'll stop there. And then we're going to plug in those x's in for this here. So we have 3 times the square root of our x plus 5. I'm going to put that x in parentheses, and I'm going to switch out those numbers. So I'm going to clear this out just to make it easier. So I have 3, and then the square root, and then I have my x plus 5. Okay, and I'm going to put in different numbers in for this x. So I'm going to start with negative 5. With negative 5 we get 0. And I'm going to make it negative 4. We get 3. Negative 3. We get 4.24. We just need a close enough approximation so that when we graph it, we can see about where it is. Negative 2. Get 5.19, or 5.2 actually. Is that 19? The 6 tells us to round up. Delete the negative 2, put in negative 1. We get 6. And then we delete the negative 1 and put in 0. We get 6.7. 1, I guess. So then we're going to go to our table and we're going to graph those points. We have negative 5, 0. So I'm going to go left 1, 2, 3, 4, 5. Then 0 stays there. Negative 4, positive 3. So left 1, 2, 3, 4. Positive 1, 2, 3. Negative 3, 4.24, so negative 3. And then up 1, 2, 3, 4. And then 0.24, so not quite halfway. Negative 2, 5.2. Negative 1 is at 6. And 0, 6.71. So a little bit above, that goes off the graph. So we get this kind of curved line going upwards. And it's going to just keep going in one direction. Because if I put in a number less than negative 5, let's say I put in negative 6, remember it's going to give me that undefined. It's going to tell me that's not close, or I can't do that. So we're going to find our domain and our range. So for our domain, we're going to go left and right, and our range, we're going to go up and down. So for domain, I'm thinking left and right, and I see from my starting point, this is always going to go right, 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 right. It's always going to go to the right. But it stops, it doesn't keep going left. So my furthest point left is negative 5. So as I look at my x-axis, the furthest left is negative 5. So when I compare x and negative 5, do I want the numbers that are bigger than negative 5 or the numbers that are smaller? And it's going to the right, so I want numbers bigger than or equal to negative 5. And then for my range, I'm thinking up and down on that y-axis. So as you can see, it's going to keep going up on that y. Keeps going up, up, up. There's always something up there. But when I go down, it stops at that 0. So there's nothing below that 0. So my y has to be greater than or equal to 0. All right, we have one more problem that we are going to do. Okay, so just one more glue in. So if you need to pause, make sure you do that. We have g of x equals negative 2 times the square root of x minus 1. And then that plus 3 is on the outside. So first thing we're going to do is we're going to find our starting point. And our starting point is where does that square root equal 0? So I'm looking only at the square root. So only that x minus 1. So I'm going to solve that equation. X minus 1 equals 0. And if you need to write that out, write that out. If you can do that in your head, do it in your head. But we're going to undo a minus 1. And to undo a minus 1, we add 1. Do it to one side. We're going to do it to the other side. And we get x equals 1. So that's our starting point. And we can go ahead and make our table. We have our x. And then this time instead of y, we're using g of x. That tells us that we're plugging it into function g. And we're going to start at 1. So I'm going to start at 1, and then I'm going to count up towards the positives. So more positives. So 1, 2, 3, 4, 5, 6. And then I'm going to be putting these numbers in to this function. So it's negative 2 times the square root, and I'll have parentheses something, minus 1, and then a plus 3. And what's really important about this is this plus 3 is on the outside of that square root. And that's really important when we plug it into our Desmos calculator. So I'm going to clear this out. Negative 2 square root, use parentheses first, minus 1. And now if I just do a plus 3, notice that plus 3 is still under that square root. I don't want that. So I'm going to delete, and I'm going to click next to it, or I can click this arrow. So then it's kind of on the outside, so plus 3. So I shouldn't see that line keep going over that. Okay, so first number we're going to put in is 1. We put in 1, and we get out 3. And delete the 1. Put in 2. We get out 1. Delete 2. Put in a 3. We get 0.17 about. So it's still positive. Delete the 3. Put in 4. And it looks like it's getting rid of everything, but it's really not. And this is negative 0.46. It's just that I don't have my screen wide enough. Okay, delete the 4. I'm going to put in the 5. You get negative 1. Delete the 5. Put in 6. And we get negative 1.47. So then we are ready to graph. So we have 1, 3. So on the graph, we're going to go to positive 1, positive 3, and there's our starting point. Then we have 2, 1. So right 2, up 1. 3, and then 0.17. So 0.17 is just barely above 0. 4, and then negative 4.6. So I'm going to go down below the 0. That's almost halfway. 5 is at negative 1. And 6 is at negative 1.47, so about halfway. And that's my starting point, so I'm not going to go past that. That's where I start, and then I draw my curve from there. That was an arrow. Real bad arrow. Alright, so we're going to do our domain and our range. So remember, our domain goes left and right, and our range goes up and down. So for my domain, I'm thinking left and right. It keeps going right from my starting point, but it stops at that starting point. I can't put anything lower than a 1. So my x's have to be bigger than 1. It starts at this 1 and then it goes on. It can equal 1, but it can't go lower than 1. Now my y's this time, they don't keep going up. They keep going down. So I want to think, what is the highest it goes? And it's always at that starting point for these ones. So the highest y is 3. So that's on my y-axis. It's at 3. But now this time, it's going to go below that 3. So it's less than or equal to 3. All right, and that is the square root function. So you do have a practice on Schoology. It's going to be asking you about some of these problems and how to start them.